The key question we're trying to figure out in this section is what exactly is heat? We talk about it and heat and the use of heat is brought about what I call the rise of the Scottish engineers. But heat is an important part of our life in a lot of different ways. We feel the heat, that's popular culture. Um, you go outside, you feel heat outside. You come inside, you feel heat or lack of heat inside. You talk about feeling cold. We'll talk about what all those mean. But the key question is, what really is heat? This is one of the things that really puzzled one of the Scottish engineers, James Prescott Joule. And Joule began looking at what heat meant. And he came up with this experiment to determine the mechanical equivalent of heat. And by that I mean he set up this little experiment where he had some water that was well insulated. He had a thermometer down in the water to measure its temperature, and then he would let these weights fall and turn these paddles. So because he knew exactly how far the weights fell, and he knew how much they had, he knew how much energy went into turning the paddles. And because he knew exactly how much energy went into turning the paddles, he could measure what that did to the temperature, and he could actually measure the rise in temperature as he basically stirred the water in a particular way, or stirred the water inside of here. And what he came to was kilocalorie, which was the unit for heat, was nothing other than energy. And he converted that into joules, which was his unit for energy. It's an SI unit for energy. So 1 kilocalorie, it turns out, is 4,186 joules. So he came up with a mechanical equivalent for heat. And by that I mean, what he came up with is how much energy, how much mechanical energy is 1 kilocalorie. Now here's the bad news for you. That Hershey bar you just ate, that was 250 calories, that's actually 250,000 calories. We kind of lied to ourselves on food packaging, so it's actually quite a bit of energy in our food, which makes sense because it takes a lot to move us around all day, and there's our basal metabolic rate, which is the rate at which we just consume energy while sitting still doing nothing. So this is Joule's experiment. He kind of worked out what's going on. He worked out that somehow, in some way, heat was equivalent to mechanical energy. Well, if you look a little closer, what we eventually found out is, in fact, heat is nothing other than the motion of molecules. All right? Heat is the motion of molecules. And if we have an ideal gas, now this is not an ideal gas over here, this is water, but if we have an ideal gas, then the average kinetic energy of that gas is 3/2 times this K, which is called Boltzmann constant, times the temperature of the gas in a unit we'll get to in a minute called Kelvin. This is called the thermal energy, right? So the thermal energy is in fact exactly equivalent to molecules just moving around. And in fact, we can predict the average velocity, or the root mean square, but we'll call it the average velocity of molecules based on just their temperature and their mass, and this Boltzmann constant, K, right? So if we know the temperature, we know how fast the molecule is moving, because we've discovered and worked out that heat and temperature is nothing other than a measure of kind of the average kinetic energy. Heat is nothing other than the motion of molecules. Temperature is nothing other than a measurement of their average kinetic energy. So let's look at water a little bit closer, because we use water a lot. There are different ways to get water moving. You could actually just drag it along. Boom, boom, boom. Translation, right? Translation's pretty simple. There are vibrational modes of water where, for instance, here I show this goes in and out. You could actually have, let me break this up real quick, ungroup it. right? So this could go in, whoop, not like that. This could be going out while that's going in, or they could both be going out. There are all kinds of ways you can set up a vibrational motion in water. This is a pretty high energy mode for making water move, and typically is up in the infrared region, which we'll get to explaining what that is. But this infrared is where we feel heat a lot of the times from like a heat lamp, right? So this is the infrared region for water. But the other mode for water isn't vibrational or translational. Another mode for water is rotational. You can just rotate it around. Now I show it rotating around the axis this way. It can also rotate this way. All right, that's another rotational mode for water. It can rotate. PowerPoint doesn't let me do that as easily. It can rotate up and down around the other way. All kinds of ways that water can rotate. But the one that we use the most often is this mode where we rotate it around an axis like this. That's because this is the mode that we get water moving in our microwave ovens. All right? In our microwave ovens, we start water spinning around like a top. That's basically what the microwave is doing. And one of the reasons microwaves make really bad ovens for cooking food is they get individual molecules of water up to 1500 degrees C or higher. Not actually all that ideal. Especially if you want to cook a turkey or something else that doesn't have an enormous amount of water content. You're getting these hot spots, and there's not an easy way for that to spread out. On the other hand, if you want to heat up a cup of coffee or soup or something like that that has a lot of water in it, maybe melt some butter, where the heat from individual water molecules can spread out quickly, that works pretty well. Another cooking tip: I cook spaghetti water. Spaghetti water. Yes, I cook spaghetti squash in the microwave oven by cooking it for 5 minutes and letting it rest for 5 minutes, and then cooking it for 5 more and letting it rest for 5 more, and back and forth like that until it's cooked. The way I actually do this is I cut it in half lengthwise, take the seeds out, trim the ends off to get rid of the stems, put half of it in for 5 minutes, then put the other half in for 5 minutes, and just swap them out until they're done. Your plates are going to get really hot because the spaghetti squash is getting really hot, and you have to be kind of careful with that. But that's, this is one of the reasons cooking in the microwave did not turn out all that well. You would have been amused by the ads that came out when I was a kid for cooking the Thanksgiving turkey in the microwave. And you would not be surprised at how badly that went for a lot of people. All right. So, just to recap so far, mechanical heat, mechanical movement, right, is the essence of what's going on with heat. Molecules are moving around. They're going all over the place. They can rotate. They can vibrate. All right? This is what heat is. Heat, at the end of the day, is the motion of molecules. All right. We'll complete this, and we'll go on in the next video to talk about temperature scales.